Now we're working problem 1435 from your textbook. This problem, actually, after reading it, it looks a whole lot like problems that are due in your homework that's due here on October 3rd. So if you're looking for some guidance on how to work some of those problems, I think this video is a good guide for you, because this problem is really similar to ones that you'll see in that homework assignment. It's formatted almost the same, and reaction and the numbers might be different, but the problem itself is very similar. It asks us to consider the reaction between carbon monoxide and hydrogen to make methanol. The problem states that an equilibrium mixture at a certain temperature has carbon monoxide concentration or molarity 0.105 moles per liter, an H2 or hydrogen molarity of 0.114 moles per liter, and methanol at 0.185 moles per liter. We're asked to compute the value of Kc. And in fact, in the problem, there's a question mark here, but I put an exclamation point. Maybe I'll add on to that, because I'm pretty excited about this problem. This is a pretty easy example for you. And of course, the reason why that is some of the wording here in this first sentence. Notice that it tells us that an equilibrium mixture, if we're given concentrations for an equilibrium mixture, boy, we can be excited about it, because it tells us what's going on in equilibrium. And if we're asked to compute K, the equilibrium constant, from that data, we pretty much just need to know how to define K and how to punch a few numbers on our calculator, and we can get this problem right pretty easy. Now remember, for any equilibrium constant expression, we define K, specifically Kc, in terms of molarities or concentrations, as the molarity or the concentration of the product divided by the concentration of the reactants multiplied by one another. These are all molarities. And keeping in mind, the stoichiometric coefficients are the powers in the K expression. So we have a 1, it's unwritten, and a 2 here by virtue of this 2 for hydrogen, okay? So really this problem, after we get to this point, is really simply just plug and chug, because these numbers are all molarities for an equilibrium mixture, okay? That's the key wording to look for, equilibrium mixture. If you're given equilibrium amounts, you can plug them in and solve. So to finish this off, all we need to do, plug in the molarity for the methanol, which we were told was 0.185 here. We need the molarity for the carbon monoxide at equilibrium, which appears to be 0.105. We also need the molarity for the H2 at equilibrium, which was stated as being 0.114. Now we've got to square that one in the math, so don't forget to square it. But we square that number, multiply by this, take 0.185 and divide by the denominator. And when we get the result, we end up getting about 136. That's our equilibrium constant Kc for this reaction system based upon the data that we're given. So real straightforward. As long as we have equilibrium numbers for everything, boy, we are in business. We can go straight in, plug and chug. If you see a question like this on the exam, you should be pretty happy about it, right? That's an example of a pretty easy one. Everybody can do that.